Okay. Okay, hello everyone. Good afternoon, Bala. I find only one person in YouTube, and I find Aditya Patel, Tushar, Kunal Gupta, Manish Pardhi. They're on the Microsoft Teams session. Welcome to you all. And Tushar Thakur, I find you have asked a couple of questions, but you have said that you are getting some error message. Now, unfortunately, I can't help because I don't see your desktop thing, right? I mean, unless I check myself over the screen, I cannot suggest you anything. So you have to come to one-to-one session. If you can arrange, I can probably suggest you more. Otherwise, just by reading your statement that you have got this error, it doesn't help. So I find only Tushar Thakur's question in the this Google sheet. Otherwise, no one else has written any question. So if you have questions, then you can ask me, or you can write in the chat box. I will try to address your queries.
Sir, I would like to ask that whatever error we are getting, for example, it is saying that certain reaction is depending upon certain other reaction. For example, water gas shift reaction is depending upon the previous reaction in which water is formed in the synthesis of methanol from syngas. So it is showing that because it is dependent on a previous reaction, it may have some error. So is there any generalized way to solve this problem? So that we mention that first this reaction takes place, then the other, and then the third. Even though I have given it in order only 1, 2, 3, still it is showing that error.
No, actually, are you following the exactly whatever I have done in the lecture, whatever I have shown in the lecture 24? Are you following the same steps? Because
yes, sir, I have.
Then you should not get any error message, because while developing that video lectures, although I have developed these video lectures 3 years back, so I really do not remember exactly what happened. But as you might see that in the lecture I have showed how to develop the model, and I didn't find any such error that you are talking about. Or if I have got any error on the lecture video, then you should tell me. Then I will revisit, and then I can address your query. There should not be any error, because I have chosen the problems in such a manner that there should not be any error message that should be. And if there is any error message, then I would have explained you why those error messages are coming.
Okay, sir.
Or Tushar, if you want, you can call me over a one-to-one video conferencing meeting, and then you can share your desktop. I can see remotely, and then I may suggest. I mean, if I find what might be the error, I can advise you further. Yeah, Manish Pardhi, you were saying something?
Sir, I have a general query, not regarding Aspen. A query regarding chemical engineering. Like I have completed my course BTech in 2020, and it's been 3 years I'm working in quality control. So many basic things I've forgotten from chemical engineering. So, sir, can you suggest any book or some source so that I can get all that back in very quick time? Because I know all the basics, but I have to read that.
Yes, Manish, unfortunately, I mean, you have to be a chemical engineer to understand the Aspen Plus simulation software. I mean, it is not like a calculator where you press 200 into 555, you'll get the answer. It's not like that. Aspen Plus is software where you have to ask, or you have to provide relevant data, and you have to choose the models relevant. You have to choose relevant models and blocks. So if you put in some junk, it will just refuse to perform the simulation. You know? So it makes your life easy, but it will not replace a chemical engineer for that matter. In other words, I would say that Aspen Plus software it doesn't perform any calculation which you will not be able to do on pen and paper. Okay, so as a chemical engineer, you should be able to solve all the problems that is being solved by Aspen Plus, provided you have the textbook, you have the relevant data handbook, so you can gather all those things and you can solve the problem. Why Aspen Plus is useful? Because it is gathering. I mean, the software has been designed in such a way that it is doing all the calculation very fast. But you should be able to know how the calculations are being done and what are the theories behind that. So if you have forgotten chemical engineering, then I'm unsure about how this software will be helpful. Probably then you have to study the basics of chemical engineering. You should go and read the table for mass transfer, or say Metcalfe-Smith, okay, or these things you have to write. Current for heat transfer, Levenspiel, Fogler. These are the books you should read and recapitulate your knowledge. Then only you can understand this software.
Okay.
Yes, Pranav Shinde has come. Pranav, welcome. And I find you have asked, you have asked several questions in the Google Mail, Gmail, and some of the questions have been answered by your fellow user Venkata. But in such situation, see, I do not regularly visit the Gmail. So in future, you can directly mail me at p.sh, my IITG email. So you can expect ready answers over there. Okay. Just now somebody wrote something in the chat. Yeah, Aditya Patel is asking, so I'm getting an error in simulation problem which was given in assignment week 6. Assignment week 6, okay. So assignment week 6, which problem are you getting? Simulation problem.
Sir, problem of Fortran code in which we have to write Fortran code.
Tell me, what problem are you getting?
Sir, can I share my Aspen window to show you?
Okay. Share it.
Yes, sir.
Go to
Is it
optimization.
visible, sir?
Yeah, visible. Go to optimization. Yeah, that is, where is the star after 1000 OPTD? AF is equal to
Sorry,
1000.
sir?
AF is equal to 1000, and after that, there should be a star, right? It is a multiplication, isn't it?
Okay. Yes, sir.
That is the problem. Go to the solver. Have you got the answer? I mean, have you got the answers of 6? I mean, this assignment 6.
Yes, sir.
Have they been declared?
Yes, sir.
Okay. Because before the answers are declared, we are not supposed to discuss it on the forum. Anyway, I hope you have. Go to your main flow sheet. Open your S1. S2. Okay, go to the properties first. Go to the properties. Run it, the properties. Run the properties first. Run.
Okay, sir.
Okay, go to simulation. Open B1. Okay, close it and open pump. Open the calculation options. Calculation options.
Yes, sir. I have opened calculation options.
Open the pipe. Close it. Open the pipe. Show the elevation. Go to thermal specification. Thermal specification. Go to fittings. Go to flash options. Go to the next tank. Okay. Now go to the optimization once again. Define. What is B3? B3 is 5. Okay.
Sir, I think unit should be in millimeter.
Yes, it is in millimeter. Unit should be in millimeter. You have written in meter.
Okay.
Write in millimeter. Go to objective and constraints. Mary? Okay, so probably he has taken it in meter, but he has made it 0.25, 0.3 and all. Okay, why don't you change it to 250 to 300 and 0.5? Right, 250 to 300 and 0.5, right. Okay, now go to Fortran. Okay. To be on the safe side, keep it in a bracket 10 to the power 17 and OPD to the power 5. Both of them you write it in. After 17 you close and before OPD you open. Right. Now you run. Yeah, now it is open. Done. Okay, so
Yes, sir.
yeah. So Kunal is asking, sir, in assignment 7, question number 8, after running simulation, we are not getting reflux profile in results as it is showing nothing in reflux profile. Is there any particular way to obtain it? Probably Pranav has already answered. Under the calculation option, you will find the option. Okay. So Kunal, Pranav has answered your question. I'm not revisiting it. Probably if you follow it, probably will get. If you do not get, you just ask me. Meanwhile, I find Rohit and Yelugu Banti Javir. They have joined. Okay, welcome you. Okay, then any more questions in the YouTube side? Poojan Parikh is asking, sir, can you please explain criteria section in R batch? Criteria section in R batch means? Guys, you have to ask me questions very clearly, otherwise it is very difficult for me to understand your question, and also what different types of times mean, like maximum calculation time and so. What is that? Your questions are very fuzzy. Okay, Pujan, are you there? Pujan Parikh? Okay, probably Pujan Parikh was asking about the stop criteria of the reaction batch reactor. That is, the stop criteria is there in batch reactor because as you understand, the batch reactors, they are unlike the continuous reactor, batch reactors, they are time dependent. Suppose whether you run the reaction for 1 minute or 10 minutes or half an hour or 1 hour or 2 hours, the output product, the product specification will depend upon at what time you finish your reaction or up to what time you run your reaction. So that stop criteria is needed until which you want to run your reaction. Okay, so that is the stop criteria, and it is very straightforward to understand. Unless you tell me exactly what is the problem that you are facing, I'm unable to help you in any further. Prince Nakrani has joined. Hello, Prince.
Hello, sir.
Yeah. So if you have any questions, you can ask. Kumkum Kedia is saying, yeah, can you please help me with adding design spec in flow sheet? I have already explained, Kumkum. I mean, if you have not understood or if you have faced any problem, you should ask me. Otherwise, those are the things I have already given in the lecture. So you please go and visit the lecture video. There, find it. Someone was asking about the, I don't know whom, in the email somebody asked me about question number 5 of assignment number 5. So I don't remember who that person is. He was having some issues with the CP, specific heat value. So in the figure, whoever it is, I don't know whether he or she is there in the forum now. His argument was the CP value is changing from 30 to 35. Probably he is looking at some other graph. Actually, the graph that I have given over here, there the CP does not change between 130 degree and 135 degrees. So it is constant at 35 kilojoule per kilomole K. So for 5 degree change, the answer will be 35 multiplied by 5, that many kilojoules per kilomole of water. And 1 kilomole of water means 18 kg of water. So per kg it becomes 35 multiplied by 5 by 18. So the answer is 9.7. Exact answer is 9.7. And the range of answer has been given from 9.6 to 9.8. So the answer is okay, within the range. And
Hello, sir.
another, sorry, somebody told.
Yes, sir. Actually, I posted that query on the mail actually, but I did
Pranav.
simulation part. I have also attached the simulation result over there in the mail itself, which shows that the CP value ranges between 34 to 35, not exactly 35. In the graph, it is मतलब we can get around 35 value, not exactly 35. It is around 34.5 something. So by simulation, we get in the range of 34 to 35. So if we consider the lesser value, that is 34. So keeping that value, we get Q value as in the range of 9.5 to 9 something that value. 9.5 to 9.8. And in the answer should be in the range of 9.5 to 9.8 if we consider the simulation result.
So okay, so this is the point 35. Okay, so this is the vapor curve. This is the vapor curve, the green one, and this green one, it goes up to 150. So from 130 to 135. So I assume that it has reached 35, and from 130 to 150 it is straight from this point to be 35. So that is the reason I have given 35.
Yes, sir.
But if you,
Visually, it is correct, actually, sir.
yeah, if you
Sir,
consider
visually
it
it
to be
is correct.
34, and yeah, then.
But after doing simulation, the result shows a different value.
So you have done the simulation?
Yes, sir.
Oh, okay. Anyway, so I have not done the simulation. Actually, if you just for this answer, at least it is part A question, so you do not need to do the simulation. You can do it from the data itself. Okay. So part A questions, I mean, you should be able to do it from the questions itself. Anyway, I note it down. If it is possible, I will extend it. This is assignment 5 and question number 5. Okay. So I'll try to increase the range so that your answer comes within the range, okay? If that helps you in getting an extra mark in the assignment.
Sir, thank you, sir.
Okay, welcome. Okay, any other question, guys?
I also have one more doubt, sir. In assignment 4, question number 6.
Right. Which condenser? Okay, actually this was a mistake by the TA. He has included total also over there. Actually, it should be total, it should be only partial vapor and partial vapor liquid. Total will not
Yes,
be
sir.
there. Okay. Yeah, I have noted it down. Question number 6, assignment number 4. I have noted it down. I will fix that answer. You will get marks. Don't worry, you will get marks.
Thank you, sir.
Yeah, Tushar is asking again. When Tushar, you have raised your hand. Ask me.
Sir, in the same assignment number 4, there is another question. Question number 7.
1 minute. Question number 7. Which of the
Sir,
following is our flash convergence algorithm for M-heat X block? Okay.
Sir, how do we know which convergence algorithm is used by default?
For that, you have to open the Aspen Plus file. So if you open this block, So here you can find the flash convergence algorithm. There are three options: inside out, gives, and user, or user defined. So in the question that we were asked, so this is the question asked: which of the following is or are flash convergence algorithm for M hit X block? So this is the M hit X block. This is the flash convergence algorithm, and we have the option of these three. We have these three: inside out, gives, and users. User means user defined. You can define your own algorithm. But Broyden, Newton, SQP, they are not there. Only gives is there. So that is the answer.
Sir,
Okay.
can you go to the convergence on the left hand side? Can we go to the convergence on the left hand side?
Here?
Below reactions.
Yeah.
There, actually, when I was doing the assignment, it was showing three different options for the convergence algorithm.
Yeah, this is flash convergence algorithm, right?
Correct.
This is flash convergence algorithm. This is the flash convergence algorithm, right?
Correct.
It's not something else. You have to be very specific what exactly has been asked in the question. So in part B, in part B, you need to go to the Aspen Plus simulation software to answer these questions. You really cannot remember these things and answer. Unlike part A. Part A, you can remember or you can see the question or graphs and you can answer the question. But part B is something which you need to be holding the software at hand, and then you should be able to answer the question.
Okay, sir. Thank you.
Okay, Rohit is asking, sir, in assignment 6, part B, I have done simulation. I have done one mistake in optimization part. So can it also affect my answer for equivalent dia Q7? Obviously, it will affect your answer because I am getting answer just out of the range. Yeah, if you have done it correctly as per the direction that has been given in part B, you should be able to get within this range. And unless you say what mistake you have done, I cannot really suggest you how crucial that mistake is. For that matter, any mistake is crucial, but yeah, Kunal Gupta has raised the hand. Kunal, ask me.
What will be the pattern of exam? we get
Sorry.
access of software in exam? We get the software access, or we will just have to answer these MCQ?
No. Kunal, actually, in exam, you won't get the access of software. So you will be having only part A type questions. By now you have understood that for part A type question, you do not need the software. For part B questions only, you need the software. So in exam also, you will get only part A type question. You don't need the software. It is not possible for me to arrange for the software in the final exam. Okay.
Okay, thank you.
Okay, Pranav is typing something. Pranav, instead of typing, you can directly ask me.
Yes, sir. I have doubt in second week assignment. Question number 5, 9, and 10.
Second week question.
Yes, sir.
Assignment?
Second assignment. Question number 5.
Assignment 2. Okay, assignment 2.
Question number 5, 9, and 10.
Okay, question number 5 is the missing data is indicated. So the missing data as indicated by E in figure 5 is, okay, so missing data indicated by E, okay, missing data E. So this is missing, right? Volume flow. So volume flow is volume flow of supply 3. It is in cubic meter per second. So how can you get the volume if you
Actually,
know that?
After doing simulation, so the value I was getting is around 0.016.
So actually, this
it
should
is not
be
in the range, like from 0.017 to 0.018.
Actually, it should be 0.25. So it should be volumetric flow rate cubic meter per second. So if you divide this by this, mass flow rate by mass density, so that will give you the volumetric flow rate. So you divide this by this, you should be able to get the value. So it should be 0.25 by 13.654. So it is 0.018. So it is 0.018. So this is the answer. 0.018 between 017 to 019. Okay. Which one else you have? Can you tell me which one else?
Part B, question 9 and 10.
9 and 10. Okay,
Yes,
for
sir.
that I have to then perform this calculation. Okay, let us do it. Stream of water flow rate given, stream of butanol. Okay, so let us go to the properties. So let us write butanol. What else? Water, butanol, nothing else. Okay, fine. Go to the methods, selected methods. This one you can delete this method. Okay. Write down NRTL, run. Okay, results available. Go to simulation. Heatex, right? So just go to Heatex. Okay, so let us write cold in. Which one is cold? Stream of water, this is 90 degree and butanol is 25. So let us write B in or butanol in, and this is butanol out. This is water out, and this one is water in. Okay, go to streams, butanol in, butanol is 20 kilomole, 25 degrees centigrade atmospheric pressure. So atmospheric pressure 25 degrees centigrade, butanol 20 kilomole per hour. Okay, Then comes water. Water is 90 degrees centigrade, 1 atmosphere pressure, 50 kilomole. So it is 90, 1 atmosphere pressure, and 50 kilomole. Then we have B1 setup. Heat test model is used. Hot stream should pass through shell side of the exchanger. So hot fluid shell side. Heat exchanger duty and LMTD correction 40 and 40 kilowatt 0.8. So exchanger duty is 40 kilowatt, right? Yeah, 40 kilowatt. LMTD correction factor 0.8. With a minimum temperature approach 1 degree centigrade has been given. Only LMTD correction factor should be 0.8. Okay, what else? Flow direction is counter current. What is counter current? Yeah, counter current with a shell side pressure drop of 0.2. Shell side pressure drop. Yeah, hot side only. 0.2 atmosphere, right? Should atmosphere. The power law model is applied to the hot fluid. So where is the power law model? Utilizing reference flow, exponent 1.5 U reference point. So this is the power law model. Power law flow rate applied to hot side flow only. U at reference point is given, exponent of 1.5. Okay. Perform a shortcut design calculation. Okay. What else? Everything is given. Oh, reference flow of 1 kilomole per hour, right? Done. So now we can run the design calculation, right? Yeah, shortcut design calculation. Is it a shortcut design calculation? Yeah, design calculation, right. So you run it. Yeah, results available. So which question you have problem? 9 and 10, right?
Yes, sir. 9 and 10.
Hot fluid exit temperature. So hot fluid exit temperature, what is hot fluid? Hot fluid is water, right? So water out. Water out, exit temperature. So this is the water out. Exit temperature is 53.27.
We need to change the duty to 20 kilowatt.
Sorry. Oh, okay. Reduce the heat duty to 20 kilowatt. Okay. It should be 20 kilowatt, right? 20 kilowatt. So the 50 kilowatt of is for 6, 7, 8. So this is for 20 kilowatt. Okay. I'll run it once again. done. So go to result summary. Yeah, it is 60.34.
Yes, sir. And
So
the
you are
range
getting
given is
60.34.
far
Sorry?
from 60.
Sir, I
Sorry?
think we have an outlet pressure as 0.2. It should be negative to define pressure drop.
Pressure drop should be minus 0.2.
Oh, okay. Right. Yeah, pressure drop should be -2. No, it is not pressure, it is pressure drop. It is pressure drop, right? Pressure drop is 0.2. Okay. Yes. Yeah, now it is 71.88 within this range. And reduction of required heat exchanger area. Okay, reduction of area. So for reduction, you had to do it from 40 to 20. So for 40, you have the thermal results. You can see the exchanger details. So reduction of required heat exchanger area. So required heat exchanger area, it is 0.0005. Okay, so let us write it down somewhere. So this is 0.00551985. So this is the one with 40 kilowatt. And for 20 kilowatt, it should be 00174964. So it is 00174964. Okay, so it will be 0.55 minus 17. So it should be 30, 40, 38 or something, right? 38 something. So yeah, it is within this range. 0.0035 to 0.0045. So that's how it is done. Okay. Okay, so guys, already it is 5 minutes over 4 o'clock, so we should end this discussion. Okay.
Thank you, sir.
Everyone. Okay, NPTEL, please close the meeting.